Welcome to the Calorimetry lab for Chem 2AL. Today we're going to be looking at the change in heat for different physical changes and different chemical reactions that will take place. So what we are trying to find, mainly by performing this reaction, is that change in temperature, which, to answer the questions at the end, will give us specific heat or enthalpy. So we're going to look at some endothermic reactions, exothermic, knowing the difference between those two, whether we are gaining or losing heat. And we will begin with getting the materials we need. So we need, to start part one, a calorimeter. So basically something to hold our solid, our liquid, and to close it off. So with this, we have a lid, make sure seal is nice and tight. I have a stirrer. This is going to let me make sure the heat flows throughout the liquid, and a thermometer to go right in the top. Right now it's at room temperature. We're going to pour some water into here and measure the temperature of that. I have some water heating. If you look in your lab manual, our first step is to get a 2/3 of a 400 milliliter beaker heated to boiling. We're going to put some metal in there. And when that metal heats up for about 5 minutes at a constant temperature, we're going to put it in our water and see that temperature change. Obviously we expect it to go up, but we'll see how much, and I'll answer some questions. So here is our metal. Let's get this on the scale. So here we have our balance. I'm going to put this, just make sure it doesn't pick up any contaminants, and I'm going to zero our scale, make sure we are getting a precise measurement on this piece of metal. So once it's at 0, place it on the scale. And so you can write down 12.729 grams as the mass of our metal. And we will keep that in mind as we prepare. So, test tube, we'll put this in. I'm just going to allow this to heat in this hot solution. It's been at 170 for a few minutes now. I will come back to this in a break in the video. Until then, we're going to get our calorimeter ready. So, no water in here yet. We're going to pour out 50 milliliters of deionized water. Now, if you are in the lab, you would get a clean graduated cylinder. Note where the 50 milliliter line is, and we would get at eye level, get some deionized water, pour this in until we slowly get to 50. And once you start getting close, you get down, you're going to be eye level with this and see where the 50 lines up with the bottom meniscus. Instead, I poured out some 50 mils for you guys. Notice that this bottom line, the bottom of this water level, we call that the meniscus, this little bubble that goes down, that is lined up with our 50 milliliter line. We're not just going off the top of the water, we're going where that indent goes down. So this is 50 mils, but we're going to find out exactly how much it is by weighing this. So before I pour this 50 mils into the calorimeter, we are going to weigh just a styrofoam cup on its own. So we're going to zero this scale, make sure there's no noise. So doors closed, exactly 0. So 3.559 grams is the weight of, or 3.558 grams. It's our calorimeter. And now we're going to pour this water in and note the change. So that's 50 mils. We have 52.502 grams. So knowing the density of water, it makes sense that this is our value. And I place a thermometer in there, get the stirring ready, and now we will wait for this metal to heat up. All right, so this water has started boiling. We're gonna let this heat at a constant temperature for about 5 minutes. While that does that, we're gonna work on part 2 of this lab. And so for this, normally if you were in the lab, I would give you one of these 3 solids, and you would determine the temperature change. In this, I'm going to give you 2. Your instructor may just assign you 1. If there's no say on it, do both in the sheet and see what each one changes with the water. So we have ammonium chloride and calcium chloride. The third one would have been sodium chloride. That's salt. Most of you would probably guess what that change would be. It's not a whole lot, but maybe do that in another lab when it's in person or even at home. But for this instance, we are gonna do part 2 with these 2, and it's basically like part 1. We're gonna start with our calorimeter. We have 2 ready to go here. We're gonna weigh this. And you're welcome to put down 3.463 grams to keep track of this math, or we can zero this out, pour our 50 mils of water in, and see what the actual mass of the water is, since that's the value we need to know. So, just like with before, I have pre-measured this 50 mils again. We're gonna look at where this meniscus is. Where is our level? And looking at that, somewhat hard to see the line, but that is about as good as 50 mils as we can. For this second part, I also have this one ready to go. As you can see, right about there, kind of hard to get it level, but with my eye level, it looks about 50 mils. Camera's kind of hard to get it straight on. So, anyway, this first one, we're gonna start with the ammonium chloride. So, here's the 50 mils going in. Make sure all this water gets out. And our mass of this water for the ammonium chloride, 48.915 grams. I'm gonna put a thermometer in here, have the temperature stabilize, and we'll be ready to go for ammonium chloride in just a sec. So now, this is for our calcium chloride. We're gonna zero out our cup. Again, I didn't put a mass now that we know of that trick. And pour our 50 mils in. Make sure all of it is out. And our mass of the water for calcium chloride, 49.050 grams. Same thing. Close the calorimeter. Put our thermometer in. Let that stabilize. We'll put the stirrers in a sec. So let's weigh out 5 grams of this sample. I'm gonna start with some weigh paper. We used a weigh boat earlier for that metal. This one's a little easier to pour. We're gonna fold this. It's gonna help us pour this out. And put it on the scale, and we're gonna zero this. Now, we get a scooper. We weigh our 5 grams. So as we get closer to this 5 grams, I'm going to slow down, make sure I get as close as I can to that value. We're at 4.9. I'm just going to add a little bit more and we'll call it good. And I'm happy with that value. So 4.967 grams, about 0.03 grams off. That is not a whole lot. Just write that value down and it won't affect any calculations. 4.968. So Let's get this in the cup. While it heats up, we will measure out the calcium chloride while keeping an eye on this, just so we're not just sitting here watching the thermometer go the whole time. If you were in the lab, you'd be a little more careful if this was your first time doing this. I have done this a few times, and so I'm able to keep a better eye on it. And here we go. So we're getting our sample out. Before we pour it in, I'm going to note what the temperature is of this water so that we can get our temperature initial and our final temperature. So our temperature of the water, 21.6 degrees Celsius. And here we go. That's all of it, and we're going to swirl. We're already dropping. We're at 19.2 degrees Celsius. Make sure all of this reacts. We're at 16.3. Keep it going. Now I want to make sure all the solid dissolves. So I don't want to get to the lowest point and realize there's still more happening. Now it's going to mess up our results. So it's on the climb. We went to 15.9. Let's see if we can get it back down. It's up to 16 now. And we're rising up, 16.1. Let's double check this. And no solid remains. So 15.9 degrees Celsius was our final temperature. Subtract the initial from the final, and that will give you your change in temperature. So put this off to the side. We're going to weigh our 5 grams of calcium chloride now. Again, we have our weigh paper, brand new. Fold it, give a nice pour to this. Zero. We have a new scooper. And notice when I finished the last one, I didn't put the scooper back in. I didn't dump out any of the solid that was remaining. It's ready to go be washed. We do that to make sure nothing contaminates our sample in the bottle. Any water molecules in the air, anything that might have been held on, it's better to keep the contents of the bottle as pure as possible. So again, this is calcium chloride now. The previous reaction, it decreased. Think about whether that was exothermic or endothermic as we get closer to 5 grams here. 4.7, we're slow down these scoops. Take it slow, nice small ones. If we did go over, all I would do is scoop a little bit off the paper and I would throw that away. Or if it was more dangerous, I would throw it into a waste bottle where it would go and be treated. So 4.967, that's pretty close to what we had with the other one. We can try and get a little bit more. Let's do that. Let's see how close we can get to 5. I don't mind going over on this. Oh, look at that. Beautiful. 5.003 grams. Set this lid back on. Let's go check our temperature. So again, I don't want to cause confusion. This is calcium chloride. We just did the ammonium chloride. Now I'm doing 2 parts kind of simultaneously. 21.5 degrees Celsius is our initial temperature. That's on par with what we're expecting. Water came from the same place. It's actually 21.4 degrees Celsius. I'm gonna check one more time before we pour this in, but it should be fine. So I'm very careful not to drop any of this. Nice part of folding is now I just grab by these corners. A nice area to pull out. So it's at 21.5. Just call it that. And let's go. So we're on the rise, 23.1 so far. Keep swirling. Bottom of the cup doesn't feel too hot. If you took Chem 5, and you saw a previous calorimeter, and you saw a change in some of the samples we use there, a few went up into the 40s, and you could really feel the heat on the bottom of the cup. This one, not so much, but we are on the rise. We're at 24.9 so far. Nice little mix in there. See what changes. 25 now. Again, make sure all this dissolves. Try and keep this lid on so that it's sealed. We might be about done. I'm gonna wait for a decrease before I call it, but it's been at 25.0 degrees Celsius for a while. Get a better view of that thermometer. It's hanging at 25. If it does this for about 15 more seconds, we'll just call it at 25. Check the solids, make sure that they're all dissolved. If it changes, then we know. If it decreases, we know the 25 was still good. One last good shake before I check. But 25.0 degrees Celsius. Looking inside, no solids. We're doing good. 25 it is our final temperature. Take that, subtract it from our initial, and we have our change. That'll help you with your questions at the end. So it's been about, well, it's been 13 minutes actually. So again, that's fine. Water's boiling. This is a constant temperature on this piece of metal. So we know that it's anywhere, at least the water is 95 to 100 degrees Celsius. The metal probably isn't that much, but it's gotta be close. Notice I clamped it up since you last saw it, when we were first setting it up. Make sure it's not touching, but all the water is just heating it. And our initial temperature for this metal is 21.2 degrees Celsius in the water. So we can see how that changes. So I'm just gonna loosen the clamp, turn off the hot plate. We don't need to heat this water anymore. Now the top of the test tube is not hot, but I definitely don't want to grab the bottom. I definitely don't want to grab this beaker just yet. And I quickly pour that in. We expect this to heat up. Make sure the water is moving around. We're already jumped up to 27. Sorry about the camera on this. At 25. Again, this is a different thermometer. This one has been in this designated calorimeter the whole time. Now I think it jumped up to 27 because it touched the metal. We just want to know what the water temperature is, so it wouldn't have jumped down that quickly just from mixing or not keeping an eye on that temperature. So I'm fine with this being about 25. Might gain a little bit more, but it's probably about stabilized now. And dropping a little. So think about what does that mean about metals? How does that transfer? Before we saw chemical reactions with those changes. This is physical. So how much heat is that metal conducting? How is it transferring it? It's a good indicator. So 25.0 degrees Celsius is our final temperature on that. I'm taking that off. I'm gonna feel this water. I'm interested. Yeah, not that hot. So again, that metal was just hanging out in an empty test tube in the water. So it's heating up all around it, but it's not, it's not like metal is on the hot plate. So just something to keep in mind. So we are gonna get ready for part 3 of this. We need 2 25 milliliter graduated cylinders, 1 molar sodium hydroxide, 1 molar hydrochloric acid. So we're actually going to pour these ones. We have these plastic pipettes, and what these are going to do is help us get near exact value for that 25 mils. We are also going to rinse off some thermometers so we can measure, or at least one thermometer. Get some deionized water. We need to record the temperature of the hydrochloric acid and the sodium hydroxide. And a paper towel at the ready so that when we measure one, we're not causing a reaction in the other one. So we'll start with the hydrochloric acid in the red graduated cylinder. We have a clean calorimeter ready to go. We don't really need that stirrer in this one since it's a liquid. We'll just swirl. Get a good view of this. So at about 23 right now, all I'm going to do, I'm going to take this plastic pipette and I'm just going to deliver in smaller quantities. This way I can control it. It's hard to control it when you're just pouring a bottle. I want to be exact in my measurements. So let's get at eye level. See that well? Not quite there. Again, we want the bottom of the meniscus in line with that 25 mils. And that looks pretty good. So there's our hydrochloric acid. Let's get our sodium hydroxide into the cylinder. And right around 24, a clean plastic pipette. The previous used one is right there. And we're gonna wipe up these tables after, make sure nothing is left contaminating these. So there we go. Trying to get best as I can, eye level for you guys. Still a little short, just a little bit more. Slowly put in these drops. And that looks good. So I'm gonna start in the acid and see what this our temperature. (21.9 degrees Celsius. That sounds good. I'm gonna wipe this off well. I'm gonna rinse it just a little bit. Wipe it again. I don't want a reaction to occur just yet. And it's in the sodium hydroxide now. (21.8 degrees Celsius. Give it another 10 seconds, and 21.9. Again, wait a sec. And so our initial temperature of the sodium hydroxide is 22.0 degrees Celsius. And let's get ready to put these together into the calorimeter. So again, this is a clean calorimeter, has not been used with any of the other samples. If you're in the lab, you would be drying your previously used ones. Everyone would probably be sharing for the most part on these. Just making sure we're doing the right steps, and we are ready to go. So let's try and pour these in at the same time. I'm gonna have our lid at the ready, have our thermometer ready to go in as well, and we're gonna pour these. And here we go. And during this, we'll be wearing safety goggles, as I am. So if you're in the lab, safety first. I already have the gloves on, and we are on the rise with this reaction. 25.9 so far, still on the rise. I can feel the warmth on the bottom as well. Something we couldn't feel earlier with those other ones, but this one is definitely already higher than them. Keep mixing. (28.1 so far. Now it's just dropped a little bit there. Let's see if that's our end, but 28.7, unless something else happens with the increase. That's what we're looking at for our final temperature. As I'm waiting for this, I'm thinking about prepping the cleanup, which you guys wouldn't have to do if you're, since you're at home watching this or wherever you may be. But if you're in the lab, there's a lot. Just make sure we're putting it back to normal. Got those spatulas, all the graduated cylinders. Again, it's hovering between 28.6 and 7, so I'm gonna just give it a little bit longer. Again, I'm not gonna show the whole cleanup. We don't need to see all of that, but there's a lot of just additional steps with this lab that happen even after the results. Waiting for this hot plate to cool down. But we're looking like we're done now. 28.5 is what it decreased to, so 28.7 degrees Celsius is our final temperature with that reaction for part 3. So make sure you get that down in your notebook. Note all those changes in temperature, answer the questions at the end, and good luck with it all. That was calorimetry.